Welcome back. In this video, we will cover the third stage of gold ore processing using the heap leaching method, which is the absorption stage. Let's begin. This stage lasts for 1 or 2 months, depending on the grade concentration of gold in the ore. Once the cyanide solution exits the heap and flows into the pregnant bond which holds the gold, as you see in this video. Through Pvc pipes as seen in the video. There is a valve called the bypass valve and another valve connected to a hose with a submersible pump inside the bond, known as the air release valve, also called the bleeder valve. To operate this system, we fill the air release valve with water to expel all the air from the hose. After that, we open the bypass valve and then turn on the pump, which will draw all the cyanide solution. We control the amount of solution flowing to the absorption columns using the bypass valve handle. If we want a large amount of gold cyanide solution to flow into the columns, we gradually close the bypass valve. If we want less solution, we increase the opening of the bypass valve, reducing the amount of solution flowing into the absorption columns. We take samples from the original bond every 8 hours, for example, to measure the gold concentration using the atomic absorption device. We also calculate the cyanide concentration in the bond through a titration process in the lab, and we read the pH levels. Additionally, we record the cubic meters directed to the heap and the columns using a totalizer meter. We will explain these procedures in a separate video focused on lab processing and another video covering all documentation and readings and recordings processing stages. So once the solution flows into the absorption column through Pvc pipes, and as soon as it enters the columns, it passes through a meter called the totalizer. This meter calculates the cubic meters of gold cyanide solution flowing into the absorption columns based on the number of rotations. There is another type of meter with a digital screen directly measures the cubic meters of solution flowing into the columns as shown in the video. These are the absorption columns designated for placing activated carbon. This carbon is made of a special porous material capable of absorbing the gold from the solution. We fill the column with carbon through an opening at the top. There is a valve called the feed valve, where we take samples from the solution entering the columns and measure the gold concentration using the atomic absorption device. activated carbon. Okay, very good. There is also another valve. After the solution enters and exits the column, we take regular samples from the valve as well, and it's help us direct the flow of the gold cyanide solution into the columns from the bottom upwards. The absorption process continues as the carbon in the first column absorbs the gold in the solution. Any remaining gold is absorbed by the second column, and this process continues until the carbon becomes fully saturated. We can determine when the carbon is saturated by taking samples from the exit flow, when the gold concentration readings from the pregnant bond entering the absorption columns match the gold concentration readings exiting the absorption columns and flowing into the barren bond. It means the activated carbon has reached saturation and can no longer absorb more gold. Additionally, when the carbon is fully saturated, we observe gold concentrations in the barren bond, which should ideally contain only water and cyanide. After this stage, we proceed to unload the activated carbon, now saturated with gold, and move it to the fourth processing stage known as a stripping process, which we will explain in detail in the next video. If you found this video helpful, subscribe to the channel. Goodbye and stay safe.